Okay, good morning, student. We'll move
Good
on to
morning,
under
ma'am.
this. Are you able to see the presentation?
Yes, ma'am.
Okay, welcome to this sixth lecture under module 5. In the previous session, we have seen how C++ can be used to write MapReduce programs using Hadoop pipes. The interface is called as Hadoop pipes, through which input and output streams can be utilized in order to process the data, and also compiling and running a C++ MapReduce program. In today's lecture, we are going to cover how to develop a MapReduce application in Hadoop and the configuration API, and how to combine the resources in order to optimize their utilization and variable expansion. Let's just have a quick recap on what we have discussed in the last session. Hadoop pipes, it is the name of the C++ interface to Hadoop MapReduce, and pipes use sockets as the channel over which the task tracker communicates with the process running the C++ map or reduce function. So these pipes doesn't directly use the input output streams, but they use it through sockets. So these pipes use sockets as a channel over which the task trackers actually communicate with the process, running the C++ MapReduce functions. Now let's write the temperature MapReduce program in C++ and run it using pipes. For that, we have seen one C++ program which we use to actually customize the map and reduce functions. And for this, we have included various header files like algorithm, limits, standard input header, and string header. And also we have used some header files, additional header files from Hadoop. They are pipes template factory. Template factory is used to create the instances, and the Hadoop string utilities header files. Template factory is used to create the instances of mapper and reducer classes, which we wrote in our C++ programming language. For this, I have explained you how the source code looks like in order to write the map and reduce functions. We have used here mapper superclass, which is already defined in Hadoop pipes namespace, and we extended it in order to customize our mapper class, which we are going to write in C++. And we have overridden the map function, which is already declared in the mapper class. And the other part of the functionality is same as we have done in Java mapper and reducer classes. We have taken the input split and extracted the year and the temperature along with the quality code, whether it is a proper capturing of the data or not, which indicates a proper capturing of data or not. Then we have checked whether the A temperature is missing or not. If the A temperature is not missing, and the quality code is any of the pre-required patterns, if it is matching any of the predefined patterns, then we write that year and A temperature in the form of a key value through the emit method into the context object. This context object is responsible to write the data into that particular object, and which carries that data from one context to another context. Here it is from mapper to reducer. I'm repeating these terminologies again and again so that you can easily remember that. Okay. So context object is used to pass the data from one context to another context. Now you are also customizing the reducer class, which is again extended from the reducer superclass, which is available in Hadoop pipes namespace. Now for this, you are again overriding the reduce method, which is already declared in the reducer class. So using this, we are trying to find out the max temperature. Initially, you are setting it to the least value in the integer. Max value, you are setting it to the least value, and then you are finding out each, as long as each value is available in the list, each temperature value is available in the list, you're going on comparing it to the max value so far available, and whenever you encounter a max value, that has to be made as the so far encountered max value that is stored in this max value, right? Now you are getting the input key from the context object, that is the year, and from Hadoop utilities, you are converting the max value, which is in integer type, into string type and writing it to the context object, again by using the method emit. Now you are also using the main function because this is the entry point for any C++ program. You are writing this main function which actually calls the method run task, which is also available in Hadoop Pipes namespace. This uses the template factory class, which creates the instances of max temperature mapper class and max temperature reducer class. This is being called as a function here. And this waits for the job to be completed and returns a Boolean value 0 or 1. 0 is the process is completed and 1 is the process is still running. The job is still running. Okay, this is how we can write C++ programs. But compiling and running it is a little bit complex when compared to Java MapReduce programs. First, we have to create a make file and then create the executable version of that make file and make it available to be spread across the cluster. For that, we are using, you just have a look at this, but you need not, as it is. Remember, why? Because it is little complex. You can directly come here to the bottom of this slide, percentage export platform, on which platform you are actually running this mapper and reducer classes. If it is on your Linux 32-bit machine, you can give it as Linux i386-32 and you make the make file ready by using %make. Now this makefile expects a couple of environment variables to be set. That is the platform and the operating system, the data model of that particular platform. That we have set using this command and we made the makefile ready. This is like executable file which can be taken up by MapReduce tasks in order to run the job. Now on successful completion, you find the max temperature executable in the current directory. Okay, this executable is an executable file which is ready to be distributed across the cluster. Now to run a pipes job, we need to run Hadoop in pseudo distributed mode. Right? You can't run Hadoop in a standalone mode. Why? Because Hadoop daemons can't be run on a single system which is running in standalone mode. So you have to set it up in a pseudo distributed mode on which you can run all the Hadoop daemons, namely name node, secondary name node, data nodes, task tracker and job tracker. All these daemons have to be up and running in order to run any Hadoop job. Now with the Hadoop daemons running, the first step is to copy the executable file to HDFS so that it can be picked up by the task trackers to which the actual job is assigned by the job tracker when they launch map and reduce tasks. For that, they are using this command %Hadoop in the file system. Use -put in order to deploy the executable file so that it is ready to be picked up by any task trackers. For that, you are using the bin max temperature file. Now the sample data also needs to be copied from the local file into HDFS because it can't directly work on the file that is available on the local system. It has to be copied into a file system on HDFS. For that, you are again using -put instead of copy from local. You can also use this -put command, Hadoop file system, put whatever is available, the NCDC data on your local system onto your file system on HDFS. Now it is ready to be run. We are actually deploying the executable file and now it is ready to be run. Means it can be immediately picked up by any task tracker once the job is assigned to it by the job trackers. Okay. Now we use the Hadoop pipes command identifier of the executable in HDFS using the -program argument. So how you do that? %Hadoop pipes. Because we are working with C++ programming language, you have to use the command Hadoop pipes and -Hadoop pipes Java record reader and Hadoop pipes Java record writer. We are setting it to true so that it can use the default Java process that are available. Means we are trying to use for our job both Java and C++ tasks interchangeably. so that you need not stick to one particular programming language. You can reap the benefits of various programming languages by making them compatible enough. Okay, for that you are using the input sample text that is from your local file and writing it onto an output file, and you are also giving the executable file available onto the HDFS cluster by using -program. Now we specify, I have already told you, we specify two properties using the -d option, that is Java record reader and Hadoop pipes Java record writer, setting both to true to say that we have not specified a C++ reader or writer, but we want to use the default Java ones, which are for text input and output. So we are using C++ as well as Java record reader and writer. C++ in the sense you are using C++ language to write your mapper and reducer classes, and you are using Java's record reader and writer in order to work with the text input and output. Now pipes also allows you to set a Java mapper, reducer, combiner or partitioner. Various types of intermediate level functionalities can be introduced in order to optimize the bandwidth utilization by using even this pipes also, like you have done in your Java interface. Now, in fact, you can have a mixture of Java or C++ classes within any one job. You can use mixture of any of these programming languages classes. Now, the result is the same as the other versions of the same program that we ran previously, irrespective of what language we have selected or combination of languages we are using. We can have the same result obtained after analyzing this NCDC data, right? The programming language that is selected doesn't matter at all. It doesn't impact or affect the output in any way. The output will be the same as in Java when we use the Java interface. Now let's see how to develop a MapReduce application. I think now things start becoming difficult, but still they're easy to understand. They're interesting to go through. So pay interest on this. We are coming to the end of this module, and these are very important things. So you have to pay focus. Now how to develop a MapReduce application. Now writing a program in MapReduce follows a certain pattern. You have to follow certain steps in order to write this MapReduce program. First, you start by writing your map and reduce functions, ideally with unit tests to make sure they do what you expect. So when you're writing the map and reduce functions, you should also associate with them some unit tests. It is like white box testing. Each and every function you write has to be associated with some unit tests so that you can immediately check whether your objective of writing that particular map and reduce function is being met or not. Then you write a driver program to run a job which can run from your IDE using a small subset of the data to check that it is working. Because you can't directly start running your job working on a larger cluster with large volumes of data. First, you have to write a small driver program to run the job, which can run from your IDE itself. So using a small amount of data to analyze that particular data in order to check whether your job is actually running correctly or not. Once it is running fine, then you can scale it up to a larger volume of data so that we doesn't have any doubts about it having any failures or whether it may encounter any failures or not. Now, if at all it fails, when we are running the job on our IDE with a small subset of data, if at all it fails, you can use your IDE's debugger to find the source of the problem. Because we have well-developed IDEs, we can quickly debug what is the cause of that failure, what is the reason for that failure, so that you can find the source of the problem and immediately correct that problem. Now with this information, you can expand your unit tests to cover this case where the failure actually arose, and improve your mapper or reducer as appropriate to handle such input correctly. So whenever such kind of context arises, whenever this kind of reason may arise, which causes the failure, then how to exactly handle it? That can be understood by running the unit test, which also covers this particular phase. Now, when the program runs as expected against the small data set, then you are ready to unleash it onto a larger cluster where you can actually start processing large volumes of data, multiple amounts of data when compared to your local system. Now, running against the full data set is likely to expose some more issues, which may not be identified with a smaller data set, which you can fix as before by expanding your tests and mapper or reducer to handle the new cases. So whenever you come across some extra issues when you're running it on a full data set, then you can easily start adding some more unit tests which can actually cover that kind of problems also, so that they may not arise in future when actually the job is up and running. Now, debugging failing programs in the cluster is a challenge. So we look at some common techniques to make it easier, because cluster has multiple machines. You have multiple jobs running on it. So debugging failing programs in the cluster is actually a challenge. So let us look at some common techniques to make this task much easier. Now, after the program is working, you may wish to do some tuning. Tuning in the sense you refine the program in order to make it more and more efficient. Now, you have to do that first by running through some standard checks for making MapReduce programs faster, then by doing task profiling. What is this task profiling? It helps us to improve the efficiency by increasing the time and space complexity. Means you have to see what is the time complexity, what is the throughput of this particular task, and what is the space complexity, how much memory it is utilizing, how much bandwidth it is utilizing. If you are able to do that task profiling, then the resource utilization can be optimized in order to bring down the say complexities in running that particular task. So after program is working, you may wish to actually do some tuning, which increases the efficiency of your MapReduce programs, so that they run faster. And this can be actually done by using what I said is task profiling. That is having a monitoring on time and space complexities. Now, profiling distributed programs is not easy, but Hadoop has hooks to aid the process. Because data is distributed across various data nodes, profiling and checking their time and space complexity is not that easy. So Hadoop provides some hooks to aid in that particular process. Now, before we start writing a MapReduce program, we need to set up and configure the development environment. Now, before going to this, let me show you how exactly a XML file for this configuration looks like. Okay, you're able to see this, right? PDF file.
Yes, ma'am.
Whatever I have highlighted here in the gray shade, you need not actually go through for presenting in the exam. You can just have a look at it to understand what is the structure of that particular file.
Not properly visible, ma'am. Can you increase the size?
Is it okay now?
Yes, ma'am.
Now the configuration API will help us to actually set up and configure the development environment. So how this configuration, how to start working with this configuration API. Now components in Hadoop are configured using Hadoop's own configuration API. It doesn't depend on any external APIs. Now an instance of the configuration class which is found in this organization Apache Hadoop CONF package. This represents a collection of configuration properties and their values. So you can easily start giving the properties and setting their values. They are actually pre-configured, and if you want to override them, you can still do that. Now each property is named by a string, and a type of a value may be one of several types like boolean, int, long, float. All these types can be used, or some other types like string, class, or java.io.file where it uses data input stream and output stream, and collections of strings. All these values can be used to set the properties of a configuration class. Now I'll show you a sample configuration file. Here the configuration read the data from resources XML files with a simple structure for defining name value pairs. So all the properties will be in the form of name and value pairs. What is the name of the property and to what value you can set that property to. That is available in the XML files. Now configurations read their properties from the resources XML files with a simple structure that is having this name value pairs. Now observe this first line. Observe this first line. It is just giving the XML version, and then in the configuration file, you're having these tags like you have in your HTML. You're having the configuration tag, which is followed by the property. Within this configuration only, you have to set all the properties with their names and values. Now, within this property tag, you have which property you are setting to. Here you are setting the property to color, right? The name of the property is color, and to which value you are setting it? You are setting it to yellow color, and the description is the property is of type color, okay? And you are ending this particular property tag. In this, within this property tag, you have set the property color to yellow. Now you are taking the next property, that is size. So that property, that size you are setting to 10. Maybe the font size you are setting it to 10. And the description is this is size property. We are just mentioning it as size. And see the next property, weight. The name of the property is weight, and you are setting the value to heavy. Now observe this carefully. You also have an extra tag here, that is final. This final tag is set to true, indicating that the user can't change the properties value anymore. Means later when this configuration file is being used, the user can't reset the weight value to any other value. It is final. It is constantly declared to have the value heavy. Okay, that is what we indicate by giving the final tag. And the description is it is the weight property. Again, go to the next one. We are giving the size and weight. Sometimes when the user can reset the size and weight, you can give it as dollar symbol. Dollar, and within the braces you give the value for that, which can be taken by from the user, which can be taken from the client. Okay, so for this size and weight, it can take the user defined values. That is why we are associating it as a dynamic value, size and weight. Okay, and finally we are describing that we are trying to set this size and weight, and ending the configuration file. Now this configuration file is trying to set what values? First it is trying to set the color, then trying to set the size, and trying to set the weight property, but as a constant value heavy. No longer it can be changed. It is constantly declared to take the weight final. weight heavy. And size and weight can be reset by the client. That is why it has dynamic values can be taken by it by giving the dollar symbol. Now, assuming this configuration file is in a file called configuration1.html. So think that it is named with the text configuration1.xml, XML file. Now we can access its properties using a piece of code like what has been given here. Observe this code in the middle of the screen. We are giving, you're first creating a configuration object. You know what a configuration object does, right? It has the client and server configurations. What all the properties you want to set for the server and the client, that can be encapsulated into this configuration object. For that, we are creating the configuration object by creating a new instance of the configuration class, and you're adding the resource from which it has to take the properties. What all properties you have set. For that, you're calling the add resource method of the configuration object, configuration dot add resource, from which file it has to consider the properties. It has to take the properties from configuration1.xml. And once this properties are set, let us just check by using the assert that function. This assert that function checks whether the configuration object's get color is same as what has been defined in the configuration.xml file. That is yellow or not. If both are same, then it gives true and goes on to the next condition. That is assert that integer size, we have set it to 0. Now, if the configuration object size is also 10, we have set it to 10, not 0. We have set it to 10, and if the configuration object size is also 10, then it gives true. Goes on to the next command. Again, assert that if the breadth and width, if at all we don't set this property, what will happen? It will use the default value. In this case, breadth has not been set in the configuration1.html. Did you observe that? We have set only the color, size, and width, and we haven't set any breadth. For that, we can directly give the default in the assert that function. Assert that configuration.get, it is giving wide as the default value for breadth, and you are comparing it with wide, whether it is properly set or not. If it is set, it returns true. Now there are a couple of things to note here. Type information is not stored in the XML file. Instead, properties can be interpreted as a given type when they are read. We have given some properties, values, which can be read from the configuration.xml file and can be used by adding it as a resource. Now the get methods allow you to specify a default value which is used if the property is not defined in the XML file. That is what I said with this breadth, which we haven't defined in the XML file, but we have given as wide as default value here. Okay, this is how you can create a configuration XML file which can be added as resource to the configuration object and can be used as the default properties for all the clients and servers. Now let us get back to the presentation. Okay, so I explained you how this configuration API can be used in order to add the resources from a XML configuration file. Now let's go on to the next topic, how to combine the resources. Things get interesting when more than one resource is used to define a configuration. Say if two resources are added by using the configuration object instead of one resource, then what will happen? For some extent you used configuration1.html. Now you added another resource configuration2.html. Then how exactly it is considered? This is used in Hadoop to separate out the default properties for the system defined internally in a file called core default XML. So some default properties will be given in this core default.xml, and it is differentiated from the site specific overrides given in core site.xml. This core site.xml file will indicate actually to a cluster where the name nodes are actually running, and it assigns the resources for that particular job. Now, from the site space, this is used in Hadoop to separate out the default properties for the system defined internally in a file called core default.xml from the site specific overrides in core site.xml. And the file in the coming up example what I'm going to show now defines this extra parameters, size and weight properties, which tells us how core site.xml can actually override what is given in the default XML file. Now the file in the coming up example defines the size and weight properties in addition to what all existing properties are already defined in the default file. For that we are using configuration here, configuration tag again, and in the property tag we are using size property, name as size, and we are setting it to value 12. And also we are taking the weight property and we are setting it to value light. Okay, this is one, these are the extra properties we are going to set than what is set in core default.xml. Core default.xml will have the default properties. Now core site XML will have the additional properties that you want to add in order to customize those properties. Okay, for that you are using these two properties, size and weight. Now resources are added to a configuration in a particular order. For that first you have to create a configuration object. You know that to add the resource by using the configuration objects as add resource method. Initially you are adding configuration1.xml. say it is a default XML file where you have set some initial properties. Now you want to override those properties. You want to give extra additional properties and you don't want to use the existing ones. In that case, you can use add resource. You're adding the new XML file, that is configuration2.xml. This file, what I have mentioned here, is your configuration2.xml file. Now this XML file you're adding as the resource to already existing features. So what happens is these new features will override the existing features that are already mentioned in configuration1.xml. Now this is explained in this slide, what I already told you. Properties defined in resources that are added later override the earlier definitions. So the size property takes its value from the second configuration file, configuration2.xml, and not from the first configuration file. So what value will be the size assigned to? It will be 12 instead of 10. Initially in configuration1.xml, you have assigned 10, but because you have assigned newly value 12 through this configuration2.xml, now the new value set to size will be 12, not 10. That you can prove by using the assert that function. Assert that configuration objects get the integer value of size. It will be, this is default. If no size is set, it will be taken as default. Otherwise, it will compare the existing size, that is 12. Now, if both are true, it evaluates to be true. However, properties that are marked as final can't be overridden in later definitions. That is what I explained you with respect to weight property. Weight property we have given as heavy and it is also declared as final, which indicates that it can't be overridden though any extra resources or any extra XML files are added to the configuration object. No, it can't be overridden any further. That is why. One second, I'll show you exactly where we have used that. Okay, that is there in the PDF file. I'll write it for you to understand. Here we have set the property tag before and we use the name as weight, and we have given the value as for that weight as heavy. Okay, and we also used final tag. I think you remember I showed this clearly. We have used a final tag in order to say that this property can't be overridden by any other extra resources or XML files added further to the configuration object. So the final value for that weight property is heavy. It is constantly declared. Okay, that is why we use the keyword final, we use the tag final in order to constantly declare some properties of the configuration object. Now the weight property is final in the first configuration file, so the attempt to override it in the second fails and it takes the value from the first configuration file itself. That we can again prove by using assert that function. Configuration get the weight is heavy. If it is heavy, yes, it evaluates to be true because we already declared it as a constant value heavy. Now, though you give any extra features assigned in configuration2.xml, it will not be taken. Now, attempting to override final properties usually indicates a configuration error. You should not attempt to override the final properties which are given in the previous XML files. If you attempt to do that, if you attempt to override final properties, then it indicates a configuration error. So this results in a warning message being logged to aid the diagnosis process. Now, administrators mark properties as final in the daemon site files that they don't want users to change in their client-side configuration files or job submission parameters. So if some properties have to be set only by the administrator. Administrator doesn't want any of the users or clients to give their own properties or change the configuration file properties or any job submission parameters. In that case, administrator makes such property as final so that they can't be overridden on the client side in any way. Now let's go on to next topic, that is variable expansion. Where exactly this is used. Configuration properties can be defined in terms of other properties or sometimes in terms of system properties also. For example, the property size weight in the first configuration file. We have seen the last property that is set in the configuration file. When I showed you in the PDF file, I have shown you how this size and weight are set. Now, the property size weight in the first configuration file is defined as $size and $weight. And these properties are expanded using the values found in the configuration. So whenever you give values in the next configuration files, these values can take up those values that are later assigned. Now you can use the assert function, use a configuration object, get the size and weight, and see whether they are 12 and heavy. That you have done, right? In configuration2.xml, you have assigned the size property to 12 and the weight property to heavy. What you indicated here is when you set the property as $size and $weight, it will wait for other resources, other configuration files that are added later to set their properties. Okay, it is like declaring them and leaving them to be defined by the subclasses, how you saw in your C++ or Java. Subclass variable definitions actually assign values to the superclasses declared variables, right? In the same way, we are doing it here. In the them, and their values are actually being assigned by the second configuration file. That is the second added resource. And that resource is 12 and heavy. So we are evaluating yes, size is set to 12 and Y is set to heavy. So it evaluates to true. This is how we can check the status of the configuration file by using assert that method. The system properties state priority over properties defined in the resource files. Now, if you want to set the properties through the system class, in that case, these will again override the already existing properties defined in the resource files through XML files. So what you do here is you are just giving system.set property. Now the new size you are setting it to 14. Initially the size was 10. Then you are overriding it by the configuration2.xml by giving it as 12. Now we are using system.set property method to set it to 14. So the priority is like this. First it gives priority to the system properties, then priority to the latest added resource, then the last priority is given to the first added resource, the property that is set in the first added resource. Okay. So least priority is given by the first added resource. If at all any other resource is added, this new values will override the existing properties, and if system properties are set, these will override the this will even override the resource files properties. And now when you're checking the size and weight, you can see that the size is now newly set to 14 by the system set property method. Now this feature is useful for overriding properties on the command line by using -d property equal to value JVM arguments. So if you want to override the properties from the command line, still you can do that by using -d property equal to value command, which is used for JVM arguments, Java Virtual Machine arguments. Now note that although configuration properties can be defined in terms of system properties, are redefined using configuration properties, they are not accessible through the configuration API. I'm repeating once again, vice versa also have to be done here. Though configuration properties can be defined in terms of system properties, though configuration properties can be defined in terms of system properties. Now, unless system properties are redefined using the configuration properties, they are not accessible through the configuration API. Hence, what are the other two commands you need to give? Once you set the property, say length property to 2, then you should also assert that configuration objects get length property if it is a string, because you are assigning it as a string here. Is string, then check it with null value. If it is true, then it will start accessing it through the configuration API. If it is not true, then it raises a warning. Why? Because it is not set in the backward direction. So it is not accessible by the configuration API. Now in the forthcoming sessions, let us see how to set up the development environment and manage the configuration files, and also use generic options parser, tool and tool runner commands in order to set various properties of the job. Any doubts, students, in the topics discussed in today's class? You have to go through the presentation or the notes given to you, lecture notes given to you once again. Otherwise, you can't remember these commands, what has been explained. Once you immediately go through, I'll send the notes today itself. Just go through what has been explained today. Otherwise, you lose touch with that, and it will seem to be a new topic once again if you open your book after so many days. So whenever some topic is discussed in the class, just go through that at end of the day so that you can recollect what has been discussed and remember it properly. Understand that properly. Okay?
Yes, ma'am.
Shall we end the class then? Any doubts?
No, ma'am.
Are you really understanding? The flow is okay with you? Or should I repeat once again this entire fifth module because it contains lots of programming concepts?
No, ma'am. Understand.
Okay then. See you in the next class. Bye.
Thank you, ma'am.
Bye.